Today I'm here to talk about a reasonably new cloud compute model that's changing how we build complex solutions. And in this talk, I'm going to walk us through how we at Nisos build an analyst-driven OSINT platform with a focus on automations. And this new model that I'm talking about is serverless. So serverless has been out for quite a while now, but I think we're really starting to see a lot of adoption within the industry. Can I get a hands up of how many people here have used serverless before or have heard of serverless? Okay, awesome, incredible. For those who haven't, I'm going to give a very brief analogy to what serverless is. So imagine you're running a restaurant, and in the traditional world of cloud computing, running a restaurant is like managing all of your servers. You've got the kitchen, you've got the staff, you've got the power supply. Now, in the world of computing, you're managing all of your servers, all of your infrastructure. So in the world of serverless, running a restaurant is like having a magical kitchen that automatically appears whenever you need it to cook some food and then disappears again. You don't need to worry about the power supply. You don't need to worry about the staff, the ingredients. It's all taken care of for you. So in the world of serverless, Lambda functions and the world of serverless is all about creating code, creating your own function execution code that runs within your Lambdas, and you let the cloud providers like GCP, Azure, and AWS take care of all of these server management for you. And of course, from a security perspective, this isn't to say that you don't take care of your security. You still very much need to do so. But you can really focus on adding code and spending your developer resources on adding the real value to what you do, which is shipping code to the end user and driving value for the end business. So throughout this talk, I am going to talk about tradecraft, and this is really important in the sense of Nisos. So intelligence analysts, tradecraft involves the use of various tools and techniques to gather and analyze information with the goal of providing recommendations and insights to create intelligence. And this includes utilizing OSINT, open source intelligence, of analyzing data from multiple sources, developing hypotheses, and on that analysis. And that tradecraft is constantly evolving, especially with the tools and techniques that analysts need to remain up to date with to stay ahead of, or if not just in line with, adversaries. So, converting art to technology. During this talk, we'll walk through the journey that we took at Nisos to turn the art of an Intel analyst and their tradecraft into a scientific, teachable, and repeatable process. And this journey was a multi-year journey that focused on people and process, and then now finally technology. In this talk, I'll walk you through the journey, technology, and architecture of how to create an automation-based OSINT platform, all centered around a serverless architecture. And this is the journey that we took at Nisos, and hopefully you can too if this is very much within your realm. So, a tiny bit about me. I am Kris Jones. I lead all things engineering at Nisos, and I've been an engineering leader at CTO, VP of Engineering, Director of Engineering in startups over the past 7 years. And in the last 3 startups I've been a part of, I've introduced a serverless architecture, and it's an architecture that I've had a lot of success with, and one that I personally really love and see huge value and benefits from. And of course, for my introduction, I'm in fact not from the US, I am from Belfast, and a quick plug for Belfast. If anyone hasn't had the pleasure of visiting the city or the country of Northern Ireland or working with a site in Belfast, I'd very highly recommend that you do so. We have a ton of really intelligent people, and we have a massive cyber and software engineering community in Belfast. You do obviously get the benefits as well, that it is slightly cheaper as well, running engineering teams out of Belfast. So if you ever get the chance or opportunity, I'd highly recommend it. There's some really incredibly talented people working out of Belfast and doing some really awesome stuff. Okay, moving on to analyst workflows. I'm going to give you the context to why we had to build a platform and go into how we built it, looking at the technologies and architectures used. And our journey here begins with analyst workflows. Through the optimization of people and process, we discovered there were many standard operating procedures, SOPs, that could and should become tech-enabled and automated that were just being done with manual process. So In the world of Nisos and what we do, essentially what Nisos does is that we attribute and find people online. Organizations will come to us with very complex questions, and our analysts will go off and then provide them with a finished piece of intelligence. And part of that journey is all about their workflows of getting an initial set of data, which could be maybe a phone number, a Telegram channel, a specific message that's been sent, and they're asked and tasked with how do you attribute and find this person and what are their motivations for that tweet, for leaking those company secrets, for being a part of a white supremacist group, et cetera, et cetera. There's a ton of varying questions and workflows that the analysts work through. So the investigations start with that initial piece of data. They then pivot and pivot again, building up a much bigger picture of what their target is, and then they then are validating that data against itself to ensure that we're actually delivering actual intelligence instead of guessing that this person might be the adversary or not. So it's all about building up that bigger picture of the target or targets, and then getting a lot of the context around the why to be able to derive intelligence from that data. So I'm going to walk through the journey of the last 12 months at Nisos, from when we went from no platform all the way through to an analyst-driven platform. So I kind of briefly touched on Nisos Analyst and what we do. We are the managed intelligence company. We plug into the heart of company security teams and help them answer difficult and complex questions. So we are a managed service that plug directly into large organizations and help them with intelligence questions that they can't answer themselves. And we have an amazing team of analysts. A lot of them come from three-letter government agencies. So that kind of gives you the caliber of analysts and the type of work that they would previously done who are now doing it in the private sector for Nisos. And our analysts focus on utilizing OSINT. So if anyone doesn't know what OSINT is, for the sake of this talk, I'm going to define it as all of these sources, as well as commercially sourced data. I know some people don't think that is OSINT, but I'm going to include it for the sake of this talk, and also for the sake of our platform, calling it an OSINT platform. So if you don't know what OSINT is, it helps provide a crucial role in enhancing situational awareness and supporting decision-making processes to allow the good guys to stay ahead of global challenges and adversaries and get an idea of what's happening on a global scale. Okay, so some of the challenges prior to us building a platform that our analysts had with OSINT is that they're essentially on their own. They're having to develop their own tradecraft, their own tips and techniques. And of course, we did have a way of centralizing this within Nisos, but essentially they're using tons of first-party web UI platforms. They're using open source technologies like Sherlock, Holhe, platforms like RiskIQ and VirusTotal. And all of this data is coming in many different formats. A lot of it's in JSON, some of it's in CSV, and then for whatever reason, some people are still using XML. So you're getting data in all of these different formats, and it's very difficult to understand and analyze and pivot and then validate your sources and all of that information. So a lot of our analysts were having a lot of tool fatigue because they're using like 50, 60 different tools for each of their investigations, and then they're having hundreds and hundreds of data files just being stored on their desktop. So not a very efficient approach for them to do their work, and it massively reduced like analyst experience and led to that tool fatigue and frustration, especially when trying to work at scale. And then one of the biggest problems that we saw was shadow engineering. So there was an internal effort from a lot of our analysts who are insanely intelligent people to create their own scripts and data normalization and transformation programs. But even though these analysts are insanely technical, they don't really care about secure engineering practices and guidelines, and all they really care about is getting the data that they need to be able to effectively do their job. And this has many like SOC 2, GDPR compliance issues, with data on local machines, lack of all-round good controls and practices, and this can definitely lead to a lot of InfoSec issues, even the likes of credential sharing. I was quite horrified to see like scripts being shared around with API keys in them, and that's of course a massive no-no. but it was all for them to enable themselves to do their jobs better. So they're improving their experience and what they're doing and being able to effectively do their job better. However, it was creating this shadow IT and shadow engineering project that we just had no control over. And I'm not saying that this approach doesn't work. I don't think we should be, from an Intel analyst perspective, I don't think we should be telling our team not to be writing scripts. I think we should be educating them. I think it helps them evaluate tools that we in engineering don't have time to get to and prove the value in them. But this can't be the way that you're developing out your Intel platform. So, building workflows and automations. For us at Nisos, this was a 3-phased approach, and phase 1 was more a consequence than strategic direction, and this might be a journey that you're able to follow on yourselves. So, phase 1 of the journey was what I'm calling the library of tools, and this was the organization getting an understanding of what tooling all of our analysts were utilizing to be able to effectively do their job. Like, what tooling are we paying for, what open source tooling are we using, and getting that into a repository of what's adding the most amount of value and communicating that throughout the organization. So there's 3 categories with this library of tooling. First of all, there is the open source projects and web platforms. So there's an amazing community of OSINT developers, the likes of Bellingcat, are constantly releasing really awesome and amazing tools on GitHub and other forums out there. And these tools are used to stay ahead of adversaries, such as scraping Telegram, analyzing Facebook, analyzing Facebook activity, Instagram, and kind of Twitter as well is an interesting one for sure. So yeah, there's tons of these tools and paid for tooling as well, and it's critical to utilize all of these tools together so analysts can get a holistic view of all of the information and data about a potential target. Then we move on to social media monitoring, and this was previously done by doom scrolling. It was searching specific keywords, hashtags, following accounts, and just scrolling for days to monitor their activity and try and find anything that might flag up as a potential red flag or a threat to an organization or person. And then finally, in the library of tools, there is breach data. As we've heard over the last 48 hours, companies are getting breached all the time. That, of course, is not good, but we at Nisos, at times, depending on the breach, we quite like that because we're able to take that breach data and then use it for attribution in future. Likes of the Capital One credit card data leak, being able to take something like that, and then that will allow analysts to be able to tie dots together. So not commercially available data, but a really nice mechanism to then validate and cross-validate sources and help attribute certain people. Okay, moving on from our library of tools. So we now have our tool set that we want to use. We know what platforms and what APIs are delivering the most value for the platform. So now we move on to the federated search. And this was the state of play at Nisos when I joined back in August 2022, where we had an idea of what we wanted to deliver, but we didn't have a platform. So this was all about creating a federated search platform where analysts can utilize one UI to essentially hit all of the tools that are possible to be hit. So for example, put in an IP address and hit all of the 30, 40 tools that are able to enumerate and deep dive on IP addresses and give me back all of the data in a much nicer format and all within one platform. And this is to combat having to download and sift through like CSV files, JSON files, using Excel for analysis, bringing everything into one centralized platform. And this was our first step towards automations, being able to create just a unified, centralized platform with all of the tooling that we had. So this is what we wanted to achieve. I somewhat apologize for this diagram. It was a lot cooler, but I had to change it for reasons. So what we have here are our tooling like username aggregation. We've got our breach data, domain aggregation, social media aggregation, phone number, and IP. So it's getting all of those tools that do all of these things and many things more into one platform. So this is the platform on the right-hand side here. So how did we build this platform? So we decided it'd be best to build this on top of serverless, and I'm excited to tell you why, and why I think if you're not already considering serverless, why I think you should be considering that and bringing that into your organization. So I know we briefly touched on what serverless is. We're going to be looking at Lambdas today, which are very specific to AWS. You, of course, have Azure Functions, and the GCP one eludes me for now. But the major cloud providers all have serverless capabilities. And what a Lambda allows you to do is you can execute a piece of code that will then spin up a VM in a server, execute that code, and then kill that VM again. And all of this happens within milliseconds. So your code only runs and exists for a set period of time and disappears again. And the beauty about this is that you only get billed for the actual time that your code is executing. So what does this look like from a serverless infrastructure standpoint? This is your traditional monolith server. A very basic example where you have your EC2 instance with Express.js running, and all of your major functions are all running within the same box. So anytime you hit an API request, that EC2 instance is servicing that specific request. If you look here, we have the likes of get user, get tweet, and get timeline. If one of these API requests is a long-running request, or for whatever reason, an engineer has pushed up a code change that makes getting the timeline like 10 times slower than it should be, this can bottleneck your entire server and very easily bring it down with long-running processes. Of course, again, this is a super simplified view of that, but you can appreciate within this monolith architecture, one wrong function and one long-running function can help bring down the performance of your entire application. So, moving on to the serverless model here, every major function from the monolith now gets its own Lambda function. So anytime it needs to be executed, it spins up its own VM and executes that code in complete isolation and then spins back down again. And the beauty about this is it can horizontally scale to thousands of instances of the same Lambda executing at any one time. So if you're getting peak usage, your Lambdas can spin up, execute, and then spin back down again. You'll get billed more for that, of course, but your servers are able, or your platform is able to handle more concentrated load at peak times, and then during less peak time usage or less usage, you're not actually getting billed for it because you only pay for the amount of time that your code is executing within the Lambdas themselves. So why is this important for an OSINT platform? When building an OSINT platform, it's very similar just to building a third-party data synchronization platform, because it's all about pulling information from open source tooling and APIs, storing that information, doing a bit of data transformation, and then displaying that to the end user. The most important thing about this is that, I mean, for us, when analysts are doing investigations, sometimes they are running hard at the attribution phase, executing many different functions and searches at one specific time, and OSINT platforms notoriously can be very slow. The likes of Sherlock is doing an email enumeration over 600 websites to try and identify what accounts exist with the same email address. So that can be very slow. It can take up to 3-4 minutes for that to execute. But when you're building this platform, you want to be streaming your data and your results to analysts as soon as you have them available. So allowing analysts to hit 60 tools at once, and as soon as a piece of data becomes available, streaming that back to the UI so they can start their investigation while the long-running tools are still running in the background, and then displaying that when that becomes available. So the most important things to consider is, of course, the short and long-running API requests. Some tools are slow, some are fast, making sure that you cater for both of them. And then probably the most important for us was defining one storage and data transformation type. We chose JSON, and we lightly map all of the tools so we have an understanding of what the data structures look like, so that can be easily processed and pivoted on in future. And that becomes really important in the phase of automations. And then finally, you need a way to ETL your breach data and be able to query that effectively. Okay, so this was our goal of what we wanted to achieve. So with serverless, here is a architecture and overview of how we actually architected that. Again, this is an oversimplified diagram. I had to strip some things out of this, but I'll hopefully be able to talk you through all of that. So this isn't a groundbreaking architecture, but it does allow us to very effectively scale up our analyst usage. It allows us to effectively add on and extend the platform. So what you have over in the far side is our serverless layer, and every tool and API that we build into the platform, it's created as a brand new Lambda. So you can create and add tools in isolation and at speed, because you have a defined mechanism of doing so with a common data storage, common request layers. So it becomes super simple to add in like OSINT tools and API requests. What we have in the middle, and this is a talk about serverless, but I don't think it's right to use serverless for absolutely everything. It's all about picking the best tool for the best job. We have an orchestration layer in the middle, which is our API, and at Nisos, we have a Django API, and that just serves all of the data to the front end, and it also kicks off all of our serverless functions as well. And very nicely, the data store at the bottom, right here, this is a DynamoDB instance, and this DynamoDB instance is used to just track the progress of the Lambdas, because we do a fire and forget on the Lambdas, utilize DynamoDB to track the status of that, if it's still processing, if it's completed or errored. So then the UI can then continually poll or just be told whenever data are ready for it to be displayed. So this was the state of play at Nisos about 9 months ago with this architecture, and from where we got to, we're now able to add in new tooling and APIs within about 30 minutes. Previously, in the old platform that was tried to be created, you're talking like 3-4 days with painful deployment and development processes. Now it's plugging in a Lambda with a tiny bit of config, and all of a sudden you have a new data source that's able to be used. If anyone hasn't came across it before, we built our project on top of the serverless framework. Has anyone heard of or used the serverless framework before? Awesome. So I'm a massive fan of it. It really speeds up your time to development. It speeds up your local development with serverless, and I think it has a really nice onboarding ramp as well from an engineering development experience perspective. So in the top left there, this is the YAML file. So what we have here is this is our piece of code to execute Sherlock. So what the YAML does in the top left-hand side is that's essentially setting up your Lambda. So you can have more complex config. What we have is pretty simple. What that will do when deployed, it will take that, take the handler file, which is what you see here, and deploy that to AWS and create that Lambda function for you. As you can see here, we have a 15-minute timeout on that, just because Sherlock can be slow, and you can tailor that accordingly. But for this amount of code, this is how we were able to implement the Sherlock project through a REQUEST API endpoint. And all we did here, don't have line numbers, but what is highlighted there is we just downloaded the Sherlock project, wrapped it in a Python function, and then call it there. And that gives us all the results from Sherlock. So we're able to implement Sherlock in like 15, 20 minutes, and of course run through all the appropriate testing. So it makes the speed of development insanely fast. And this is the type of results that Sherlock gives you back. So this is an example of the JSON files that our analysts were having to deal with. You can see this isn't very nice. I think this contains all like 600 websites that Sherlock tried to hit, and tells me, does this email address have an account on this platform? This is incredibly difficult to understand. Of course, when you do it more and more times, you become faster and more efficient at it. But again, this is not the most optimized way to be able to be doing your analysis and pivoting on data. So when we brought it into the platform, this is what we went from. So from this to this. And this is a super simple UI. It's just taking all of the headers from Sherlock, from the JSON file, and dynamically building up a table using AG Grid in React. So nothing super complicated going on here, nothing magical, but from an analyst experience perspective, just creating this very simple UI platform on top of those JSON results, it makes it a lot easier to understand, pivot, filter, and search all the data coming back from those OSINT tools. So in summary, from a federated search perspective, some of the main benefits that we found from doing this are that our product and Intel leads can start to analyze tool usage. Some commercially sourced tooling can, of course, be insanely expensive. And with this centralized platform, we're able to wrap analytics and usage and value around a lot of the tools and data that we get back so they can make more educated decisions on tool spend and engineering effort with specific areas of interest. Yeah, that's the second point there as well around strategic decision on tool spend. Also from an onboarding perspective, this makes analyst onboarding like 10 times easier, if not more. Previously, they're having to get up to speed with all of these different web UIs. Some can be very complex and cumbersome to utilize. There's like one password credential vault for logging into all of these tools, all really quite messy. And now from an onboarding perspective, it's here's our Nisos platform, here's all the tooling that you have available to you, and here's what that data means. It becomes a lot simpler and easier to do. And then finally, there's no longer parsing CSVs or JSON. It's one UI for all of the tooling that we have internally. So now we have a architecture and platform for federated search. We can now start to look at creating automation workflows. You're glad to hear the hard piece is now done. The federated search is by far the heaviest lift. And the beauty about what we have just built, we can now start to chain API calls together to build out complex attribution workflows and data enrichment. And the key part to all of this and creating the automations is having an orchestration layer. The orchestration layer that knows and understands what lambdas to execute and chain together. It knows how to await the results, and it knows how to parse the results. So if you look at the Sherlock example that give me all of the email addresses and accounts, we're able to then dive deep into that specific Sherlock response, grab the email address and username returned, and then do further data enrichment from there. And that's all possible to do because we understand the underlying data structure of what that tool result looks like. And from there, you're essentially building out a if this, then that model for your automations. And here is a super simplified view of what the orchestration layer looks like. You have your Lambda function executing, storing the data in S3. You're then passing that data to the next function, doing if this, then that, executing and enriching your data as you go along. This is, of course, a very simple view, but more complex views can allow us to go from a obscure Twitter handle all the way through to a person's like LinkedIn profile, work, address, and potentially like their travel and flight history as well. So going from something very obscure, like a Twitter handle, all the way through to here's an entire profile on this specific person, all done just by creating automations, which previously would have been the analyst having to know what tools to hit, know how to pivot off that information, and that's kind of taking that art of understanding the tradecraft and turning it into this scientific, turning it into a scientific automatable process. So this is a brief example of what that orchestration layer can look like. It's all about just mapping the properties that are interesting for you in those results, especially in complex JSON structures. What we're able to do is recursively look through that array of results coming back and pull out the likes of username, site, status, user URL, etc., just by using these one-line properties, writing a bit of recursive Python, nothing over the top and complex, that can go in and grab me out all of those properties. So you're essentially, from an analyst perspective, going from the ugly JSON to a really nice UI, so it's a lot simpler for them to create those automations. From a benefit perspective, it allows us to auto-enrich results. So when you're doing initial searches, it can go off and find all the extra information about that data and information. And it allows you to create automations as jumping off points for investigations. If a client comes to us with a phone number, a Telegram handle, it allows us to plug that in and then auto-enrich all that information to make it a lot easier for analysts to kick off their investigation and making all of those cross-validation requests. So in conclusion, for us, this enabled our analysts to create their own automations via an automation builder. So we're empowering the analysts to take their knowledge and tradecraft and put it into the platform so this can be scalable across the entire organization. And for us, as we utilize the federated search and gather all of that information about how analysts use the platform and what they are finding valuable, we're able to gather all of that data and start to train AI models to then start creating automations for us based on their usage and how they're finding and validating all of the data within the platform. And for us, the automation journey was all about the federated search and making that experience super intuitive and enriching and giving them as much information as possible. And that was the heaviest lift. And the automation piece on top of that was roughly a quarter's work for a couple of engineers. So definitely not the heaviest piece of the overall project. So we walked through the journey that we took at Nisos to turn the art of an Intel analyst into a scientific, repeatable, teachable process. But all of this tech that we built was to empower the analyst. It was to make their job better. It was to increase their experience. It was to reduce frustration and help them do a better job. And we at Nisos are not building this tech and platform to replace our analysts. We very much pride ourselves on being technology driven and people perfected. Especially in the world of tracking and finding people, we definitely believe this and know this, that it takes people to find people, but it's around creating the technology and tools to empower them to do their job best. And that's it for me. Thank you very much. It has been a pleasure to be here and present to you today. I'm about for questions now, and I'll be hanging around here. I think my flight home is at 9 p.m. tonight, so if anyone has any questions, please reach out. But thank you, everyone.